Hello there. Thank you for watching. My name is Jan Dijers, Integration Architect specialized in Azure and Boomi integrations. Um, this will be a video, a full deep dive in how you can, in my opinion, best set up tracing from functional and technical perspective in Boomi. I have another video which is a bit more high over, a bit more like a nice demo on how it actually works. But I also promised in that video that I want to make a deep dive where I show every part of Boomi on how it is exactly set up. Yeah, and I hope this video helps you with that. In case you have any questions after the video, feel free to leave a comment, reach out. I'm always happy to help. Know that I will create an extra blog for this into my blog yandars.com, and it will get some step-by-step details. I will also create an extra repo in my GitHub. It will contain a markdown with a lot of information, and also all of the data models I use in this demo are there as a nice JSON schema. Okay, enjoy the video. Okay, very short, the architecture. We have an order stream. The business case from this perspective is that some business person wants to know where order XYZ is from customer ABC. Doesn't matter. We are going to make sure that we can search that order and customer back into our Boomi environment. Next to what we are going to use is tracked fields. We are going to have an elastic dashboard. The elastic in this case, of course, you can use whatever you want. I just used elastic because it's easy to set up. I also have Azure API application insights on top of my Azure API management because it's handy. Let's get started. So the order goes from system A over Boomi over Azure API management into system B. We have some schema validation over here, but let's get started at the start. So what we have over here is our Boomi environment. In this video, I will touch every little component. So our Boomi environment is split up into two parts because this is just an easy demo. We have our order processing and we have our tracing. And our order processing is split over two processes. It's the imitate send order and it's the main order. And the ID behind this is that for my demo, it's easy to imitate it, that I'm system A. I can do that by like this. I can imitate that I sent a successful order or a non-successful order. And this process does the actually logic and is separately deployed and we trigger it by that order process. Easy peasy. So what do we do over here? First, we set trace properties. What I have in my blog, I will make sure I share with you a list. It will not be this exact way. I will form it a bit nicer, but the idea keeps there. So we have these dynamic document properties and these dynamic process properties. I had a good thought about which one should be document properties or process properties. I do it with a reason. So understand that. So we do that here. In this case, I set the unique value for the correlation and activity ID. Interface code is 1. Always use a unique interface code per Boomi integration. It's very handy for your traceability and to make sure that it's matching with your documentation. I get the interface name. I always use a standardized name for my systems. And I like to keep it within the 5 characters, and it's also part of my documentation. So we have sys A and sys B, and in this case it's in the domain order. On other properties, very important, the parent status. So within our functional trace, we keep track of the state of the process. It's progressing, or it's succeeded, or it's errored. The action, in this case it's empty, but you can imagine for a functional trace we want to say we are now starting to process this order or we created this order successfully. That type of information we put into the action. severity info or error status, and all of the Boomi execution information, always handy. And for our tracing, we use a schema. In this case, it's schema 1.0. I can imagine it's a bit abstract like this, but no, I have a JSON schema. I call it the trace log message, and all of that properties and everything is also over here. I have a nice example view how the message also will look like in the end, and this is the ID. So we get the correlation ID, activity ID, and over here we push some metadata from our integration. It will be part of this video where I explain how that works. So that's that. Here we just have an example order, doesn't really matter. The schema of that order is also in the GitHub repo. I will share it with you like this. And also for system B, I have the schema, so you can just follow me along the way. So over here, I have a Boomi queue. Maybe you wonder, why do you use a Boomi queue, Jan? I'm not a big fan of it. Let that be first, but for this demo purpose, it's easy to use Boomi queue because it's part of the sandbox environment. I'm an Azure guy. I like an Azure service bus like 500 times as much. We have full control over the delivery count, over the peak log mechanism, and the dead letter queue, and about resubmitting. But to keep things simple, I have this order queue. And in this order queue, I just pushed the order. Very easy. Let's not spend too much time on this. And after it's pushed into the order, this process is done. Now our main process starts. What we have over here, we listen to that same queue. And over here, what we have enabled is the tracked fields. You wonder, Jan, when I go over here and I try to add tracked fields, it's empty. That's because you didn't add it yet. So what you do, you go to your organizational Boomi account, and all the way down here, it's a bit hidden. You can add your tracked fields. In this case, I added the order ID, a customer ID. Do know a maximum of 20 tracked fields can be added. So be a bit cautious about what you add. You can also use more commonly used yeah, fields. For example, search field or record ID or whatever. Okay, that's that part. So I make sure I can search like this. We go back to the process. Now we set again our trace properties. But what you see, instead of resetting a unique ID, I use the dynamic document properties from the previous process because it's very handy, because if you have multiple processes chained like this, we can use that same correlation ID and activity ID. Very handy, very handy. For the rest, nothing changed. So here we have a try catch. Nothing strange about that. And then we move into our first sub-process. This is the place where things gets interesting. So to understand what we actually do over here, I have to move back a bit. So what we do, we set the metadata. I always use my activity ID as unique key to add information to my tracing. And out of the input, I get my customer ID and the order ID. And I do that because then I can search on the tracked fields within the Boomi environment. Next, I store it into my cache. And what you see in the cache, it's part of this. So I have one JSON profile with my tracelog message. As I mentioned, you can import it from here. It's just a one-on-one copy. And I actually relate activity ID with certain metadata key value pairs. And we will use that later to connect the metadata to the trace message which we have. So why is this really nice? We can using this, we can connect our metadata to our trace message that we can always search on the metadata, for example, the order ID or the customer ID. Yeah, I will come back for this later. So that's this part. Now we come at the interesting part. So the business person wants to know what happens with my order. What we do over here, we let the functional trace know that we received the order from system A. So that from functional perspective here, oh, the order reached that phase. They now start to process it. And it's just the info and yeah. But what we do, I have a process route behind it. Always use a process route when possible when you reuse processes across multiple processes to make it more maintainable for the guy who comes after you. What we do is based on the schema version which we set, in this case at 1.0, we have a create trace message. Why do we use DPP schema version? We use that to make our tracing backwards compatible in case we have certain field changes or breaking changes. Then we can just add a version and make sure that both can work next to each other. Here I have a very easy set activity ID. It's just a JSON where I set the activity ID so I can match my trace with a certain activity. And that's very important because if your activity ID change because you debatch your documents, this will make sure that the proper metadata is attached. So be careful with that. Next we have this map. I know it's a lot of different things, but what we do is we connect the document properties and process properties with the trace fields. So all of the information we put here in the set trace props, we connect over here. And I know it seems a bit chaotic, but you only have to set up this once, and this is your tracing framework. So yeah, we just need to accept that part. So out of that, we get the trace message and we put it into a trace queue. And that's the end of this part. And this was the happy tracing part, but the unhappy flow I will also explain right now. So in case we reach the catch shape, we set it to failed, we put the try catch in action, we set the converted to error, status to failed, and we send the end stamp. And instead of that generic get or send to ASB process route, we will now have a different one. All. And the only difference with the other one is that we have a branch over here, and in that branch I throw a generic exception to the current data, so that's the output of that tracing message. What I want to show you is how that looks like. So 1 second. I just continue to make sure we move along quickly. I'm also a busy guy. So very good. So back to the sub process over here. So what you see, we start pushing the tracing. We have a simple map over here to go from system A to system B. And then we return the document. And because we are finished with the map, I send another trace, order system A transformed into system B order. You can of course add for each context extra tracing. It's just from my perspective a functional question on what does the business want to see of this order. Maybe they only want to see something when it fails, eh? But yeah, that's of course the question. Back to our main process, and the last step of the process is to push everything to system B. So we have here our REST endpoint, and over here we have our set trace finish. And now we set our parent status to success, action to order created. severity info, status is success, and an end timestamp. And we just keep using that same queue. So it just gets all the traces, all the errors, it's in the same queue. And we will just have one simple process that actually picks up the message from the queue and push it to the Grafana endpoint. And I will now showcase that part. So a very simple one. So we listen to the Grafana queue. I set some properties again because this is a new integration for me. You also see a new interface code there, interface 2. For me, this is just a completely new thing. So because we are going from a Boomi environment into some elastic environment, and I also want to trace that. It's a bit of inception if you think about it like that. But then we have our endpoint over here, and we push it into into the table. No worries, I go into the Azure part a bit later, but I first want to finish the Boomi stuff. I have a simple application status check here, and we check if we got a 2 or 1 back. Otherwise, we throw an exception, and that exception, as you have seen before, is pushed into the try catch message as an action, and you see it as an error, and it will result in an error case. So that's that part. Now I will be demonstrating it. So first things first, I'm going to create a new order ID. Let's call it the SO1600 from customer 2050. I'm going to save it and push it. Well, it's finished now, so it pushed the message to the queue, and this process is separately deployed, so it should have been triggered. So I have a filter over the last hour. Oh. What I didn't do is, normally I would set this to low latency, so you don't see the processing of pushing the events to the elastic, the tracing, and also the time which will be needed is a lot shorter. But here we have our order. What we see, we listen to the queue, we posted it to the system API of order of system B, and we pushed the 3 trace messages. So it was the started, transformed, and finished. Now, the main question of the reason why we want to have this tracing is we want to be able to search on the order ID. And if you have a lot of processes running, you cannot find anything over here. So what you do, because we have set up the track fields, you can say I'm going to search on user-defined track fields. In this case, for example, the order ID. I stored it on my clipboard. And you see, I can very easily find it. So if this process took place a week ago, I could have found it. As long as your documents are stored on your runtime of your process, it's easy to find them. But yeah, we can do it on all the fields we defined as track fields. This is the process. I can say load execution. Now we will get to that default executions overview where we can see our process with that specific ID. We also go over here and we can see that ID over here also. So all these fields we use as track fields, and it's very easy to search on it. So we also said it was customer 2050. So for the next demonstration in the Elastic, we are going to search for that customer 2050. There we go. I'm going to search. And now we see the complete process. So we received the order from system A, then we transform it into system B, and then we pushed it into, and the order was created. I have all the trace fields we have over here, so we can just filter on all of those, and I can show them here. But this is just a very easy representation of why this is very handy. And you have to use a bit of your imagination how you will actually use this in a real life scenario, where you maybe put a bit more of a dashboard on top of it. But what we can of course also do is we can filter on the severity, on the status, and if you are a bit more familiar in Elastic, you can set up alerts based on whatever we push to the tables. That is very handy, but this demo is, I think, already big enough that I keep it with this. So that was mainly the Boomi part and the Elastic part. I now go to the Azure part. So what we have over here is two different APIs. You have the order API, and within the order API, this policy is also into the GitHub. I have a mock that I say whenever everything's good, I just return a 201. And I have a validate content. And this is something I see a lot of people forget, because what's very handy about Azure API management is that you can just say you upload some schema, and when someone calls an API, you actually are going to validate that schema against whatever is pushed. So if something is not according to the schema, you will get an error. So that's also what we see here. This is a good order, so we get a 201. And now we are going to the unhappy flow. And in this case, I say I don't have an order ID. So here we have order ID, and this one, no order ID. When I push that, we get this back, and we see over here that we miss from the object the order ID. So what I will do, I will change the customer again to the, let's say, 2075. I copy this one. I go back to my Boomi environment, and instead of the happy flow, I'm now going to push the unhappy flow and no order, but it will of course work with any field. I'm going to mutate again. Because we don't have the order ID, we can unfortunately not search on it, but we do have the customer ID. So in this business use case, if we have this type of issue, we could ask for the customer number. And we can search also on it. So I'm going to add a user-defined fact field customer ID. Oh, and I want to search on it, but I copied something. Yeah, there we go. And now we found it. And I see we have an error. So something went wrong. So I can say now load execution. What happened with my order? Oh, I see now we have that trace message, which we set in the exception shape after we catch it. We see it over here. So we have all of our information. We don't have the order ID, we see. So that's already something. And now here we have the API response. And here we see that the order ID is of invalid type because we got a NULL. So that is the exact response we saw on Postman because we didn't send the order ID. That is a reason to have a discussion with the business on why didn't they send it. Of course, in a real life scenario, you want to have that schema before it enters your integration system. So the application A already knows that they have screwed it up. But in this case, yeah, it's an example on how we can control these type of things. So we push now the customer. I can see again which information I have in my track fields over here. I can, for example, search on the correlation ID, activity ID, or on the customer ID. But for this example, I again go for my customer. And we see now, instead of everything succeeded, we now see that we received the order, that we transformed it into the system B format. But here we see that we have an issue. So something is broken. So here we see again that same issue here. So order ID is of invalid type. An expected string was expected according to the JSON schema, but it got NLL. So now if the business person has a nice dashboard on top of this and they see this, they know, hey, wait, that integration didn't got the order ID. And of course, you can modify the message a bit more to your liking. So some less technical people also understand it. But yeah, this is already a good representation, I guess. So that was the elastic. But that's not all. If you know me for a little bit, you know I'm very much into Azure. One side, I like it very much because yeah, we can define everything as code and we have a lot of unit test options. But next to that, what we can do actually, when we have an API, we can say we are going to connect application insights to it. In this case, I have my application insights Jan Dares demo app. And we can say that we log uh, the request or response bodies. That is something very handy because if we get a question like this, instead of only relying on Boomi or on Elastic, we can also do an end-to-end research on App Insights. So when we are over here, I can again search for that customer. I see over here we got an API call. And we see exactly again what was the request body and what was the response body. So this is also very handy when we do some research. But again, from my perspective, this is also a bit more technical. And yeah, as you see, I have here my Azure API management instance. I can put an unlimited amount of APIs over here, connecting to all different type of systems. And from Boomi perspective, it's a single connection. So I hope not a salesperson from Boomi is listening, but this is a great way to save on the rest licensing. That's that part. Let me think. Going back to the plate, I think I showcased everything. Yes. So this was the video. I will make a blog about it in the description of this video. I will make sure the links are there. And if you face issues, feel free to contact me. I'm always open for a technical, challenging discussion. Have a good one. Bye bye.